Tonight, we have Sean McDonough. He's the CTO for the Pate Group, based out of Cincinnati. They're a Microsoft partner. He's famous for his Sean McDonough Had a Farm t-shirt.
Jeez.
Which people probably don't remember, but I do.
We keep hoping.
Yeah. He has many Microsoft certifications, got 2 decades of experience with developing software infrastructures and IT. He's an expert in a lot of different fields, deep dive expert. I want to call him a technical honey badger. Sean is also a recent MVP. Let's let him take over, and he can fill in any gaps, and everybody should be seeing his screen. So I'll monitor the questions. Just raise your hand or ask a question, and I'll jump in. I'll try to facilitate the question. All right?
All right.
Okay, so Sean, it's all yours. Go ahead.
All right. You guys still hearing me okay?
Yeah. We hear you. Perfect.
Perfect. All right. Well, this is Designing for Optimal Performance in SharePoint Online. Tom, thanks for the introduction there. Yeah, I was lucky this year, back in April. Last year I was awarded MVP. I'm a developer, IT pro kind of switch hitter, so that's why I'm in office development and office servers and services. So the reason I want to point that out is because you will hear me at a couple points in this presentation kind of give developers a hard time. I just want you guys to know I have nothing against developers. I'm a developer too. But I like to pick on developers now and again when I'm giving IT pro talk. So in any case, this is primarily a developer talk, and so we'll be talking about all sorts of things that you can be doing for SharePoint Online, as well as how to diagnose some performance issues and hopefully troubleshoot your way out of some problems should they arise for you. So let's see here. Let me make sure my clicker is working. There we go. So just a couple seconds about the Pate Group. As Tom mentioned, I'm the CTO for the Pate Group. We are based in Cincinnati, Ohio. We're kind of unusual in that for those of you who know Mark Rackley, the SharePoint hillbilly, he and I are co-workers, as is Stephanie Donahue. The three of us are fortunate enough to be MVPs, and it's nice to be working with people like them, kind of delivering services in the SharePoint space, writing custom applications, and traveling around speaking, things like that. If there's ever anything we can do for you, feel free to reach out. I think most of us in Pate Group are pretty accessible. You can find us online. But I thank them for their time today and letting me share this information with you. So here's what we're going to be talking about. The agenda today is pretty loose form. Like Tom said, if you guys have any questions, please feel free to jump in and ask. Or if you want to wait till the end, that's fine too. Everything you're seeing right now, I've already gone ahead and uploaded the PDF of this Prezi that I'm showing you. It's on my blog, which is sharepointinterface.com. I'll have that at the end as well, so you don't need to write anything down if you don't want to. But everything I'm sharing with you, and there are plenty of references at the end. Pretty much everything I talk about has a reference at the end of this presentation, so that'll be available to you to download. And like I said, it's already out on my blog. So we'll be talking about the SharePoint Online implementation. Not too many people know too much about how SharePoint Online is implemented. And I like to spend a few minutes starting there because with an understanding of SharePoint Online, it makes it easier to understand some of the behavior you might see and occasionally some of the performance issues you might run into. So we'll talk about the SharePoint Online implementation. We'll also acknowledge what I call the reality of plumbing. I'll spend a little bit more time on that in a second, but when I'm talking about plumbing, I'm talking about the network infrastructure that sits between your client workstation and SharePoint Online. It is something of a factor, and we need to keep it in mind whenever we're dealing with cloud-based services. So I'll spend a fair chunk of time talking about SharePoint Online diagnostics and tools. Many of you have all the necessary tooling available to you right now, whether you realize it or not, to do some baseline troubleshooting. And so I'll go through that and how it works. The bulk of the presentation will be design and development guidance, some samples and examples throughout, and of course Q&A throughout. And like I said, I've got references at the end. So without further ado, I need to make one announcement. I need to point something out. This is almost a requirement now. But first, I want to share an important note because this is basically my safeguard here. My important note, this is Office 365, and some of you might be wondering, well, why on earth do we have a Christmas tree up there? Well, as Microsoft will tell you, Office 365 is an evergreen service, yes, which is basically their way of saying it's always changing and updating. And any of you who have Office 365 right now know that when you go in to look at your service dashboard, there are all sorts of things happening all the time. You'll also, most people get push notifications letting them know about changes that have taken place over the last week. You can go out to the Office roadmap.office.com and you can see what's coming, what's rolling out, what was canceled, what they plan to do in the future. I mean, Office 365 and SharePoint Online are constantly changing. And for many people that's exciting, but for many other folks it can be a bit of a challenge. Particularly those people who write courseware. I have a few friends who develop courses and training for SharePoint Online, and I think those folks are probably drinking really hard right now because things keep changing so much. I had one friend here in Cincinnati, Mike Smith. He had developed a brand new course for SharePoint document libraries, and he finished it right before the new document library experience rolled out. So guess whose screenshots and basic walkthroughs were all junked in one fell swoop. So I felt bad for Mike, but that's kind of the way that things are these days. So what I'm going to show you today will probably be true tomorrow. Of course, there's a good chance it'll be true next week. Might be true in a month, might be and probably is worth questioning and reevaluating in a year because things are just going to keep changing. So please don't dig this presentation up in 5 years and send me hate mail because I presented something that's no longer accurate due to a service change. This has happened on my blog before. Back when the SharePoint 2013 rolled out, I did a handful of articles on what was then the new app model, became the new add-in model. Just maybe earlier this year, I had somebody put a comment on one of my very early app model blog posts and say, it doesn't work like this at all. Like, did you look at the date? The date says 2013. You're right, it doesn't work like that anymore, but that's the nature of what we're doing here. So don't send me hate mail in 5 years. And if you agree not to do that, I'll keep going. All right, I'll keep going anyway. I just have to beg forgiveness if something changes. So our first stop here, some basic SharePoint farm architecture, and of course, why that matters with SharePoint Online. Most of you are familiar with the proverbial SharePoint farm. They come in many shapes and sizes. Everything from the small farm, it can even get smaller than that. There's always the single server environment that many developers use, and folks who are just getting started with SharePoint, they want to stand up that one environment, they'll dump everything on a single server. And of course, as everybody knows, SharePoint scales out and scales up very nicely. As we start to get to larger and larger numbers of users, our farm architectures start to sprawl out. And it's not uncommon to have a couple dozen servers in a SharePoint farm, particularly if you are dealing with high availability scenarios and redundancy and those sorts of things. So it might be easy to think that SharePoint Online, and you'll see this SPO all the time, I'm talking about SharePoint Online, is simply an extension of this pattern. And the truth is it isn't, or at least not really. I mean, yes, the farms are certainly larger. We don't even call them farms in SharePoint Online. Most of you probably know what this is. It's a stamp, right? Well, the term stamp is relevant because a SharePoint Online environment is also known as a stamp. And a stamp contains everything that's necessary to run SharePoint Online. So every time you set up SharePoint Online in a tenant, you're basically located within a data center in a couple or more stamps. The reason it's a couple or more is to cover high availability scenarios. So within a data center, we have multiple stamps for high availability. And these stamps contain everything from the stuff you'd expect with SharePoint, which is web front ends, application servers, search servers, SQL servers for your data, all the AD infrastructure that's needed, SMTP and email routing, all of that stuff, as well as all the identity stuff we need. And across data centers, we have additional stamps in other regions for failover, redundancy and failover. So for some reason, your primary data center where your SPO implementation or your tenant is located becomes unavailable. With some delay, you can fail over to another region and still have your SharePoint environment. So these, these stamps form the functional unit of a SharePoint Online implementation. Looking at the representation you see here, you might be inclined to think that this is only 16 servers, that a stamp is 16 servers. Well, are you ready for the kicker? This is the one that throws people off sometimes. The exact number of servers in a SharePoint Online stamp is actually variable, and it can be changing at any point. The reason it's variable is because the number of servers that are provisioned in the stamp, and these are all virtual servers, they're provisioned to try and keep the CPU utilization at about 40% on those web front ends. Now, as utilization rises and CPU utilization rises, usually due to increased traffic and activity, there is a process by which additional front-end servers are provisioned and added to the stamp. And if load happens to drop so that your utilization is particularly low, some of those servers may be decommissioned because, again, we're talking virtual servers here. There are scripts and there are processes to spin up and spin down these servers. Now, it's not instantaneous, so it doesn't mean that we've just been sitting at 80% utilization for 5 minutes, 30 seconds from now, we're going to have new servers. It takes some time. The reason I point this out, just with a little forewarning, if you know this and you understand how this operates, let's say that you're getting set to roll out a new SharePoint Online intranet or set of sites for your users. If you expect that to be rolled out to a large number of people, you would be doing yourself a favor to stage how you add users to that site. You may add a certain number of users at 8 in the morning and then open it up to others at 10 and then 12, because by doing that you allow this automatic provisioning process to slowly ramp up the number of web front ends, and so it guarantees a better a user experience that's better than if you suddenly turn it on for 10,000 users and the farm gets swamped. So that's one thing you can do, just kind of an aside, in the event that you're rolling out a new site, is stage it. But the main reason I want to get to stamps, elastic capacity, and making sure you guys understand that is to fight one problem that I'd like to say I don't run into very often, but I've seen it and I've dealt with it with a number of different customers and in conversations with people. People, for some reason, want to load test SharePoint Online. They want to fire up Visual Studio Test Edition or Mercury Loader Runner or whatever, fire up their test generators and try to swamp SharePoint Online. Load testing is futile because all you're going to do is test an instantaneous capacity of that stamp, which is then, of course, with increased load, going to turn right around and provision additional web front end. So your load testing isn't going to give you any usable number that's consistent for any point in time, because what you're doing is you're fighting with this provisioning mechanism. Now, at the same time, if Microsoft detects a whole bunch of load testing traffic coming into an environment, guess what? They're going to throttle you too. So load testing, there's absolutely no point in trying to load test SharePoint Online. And if any of you end up with management that tries to push you down that route, feel free to reach out to me. I'm happy to have that conversation and help support you in that. So there's no way to test it, and rather than load testing, what you should be doing is focusing instead on the items we're going to be talking about for the rest of this presentation. It's best for us, if we're trying to deal with performance and performance-related issues, to focus at the page level. And most of our guidance here is going to be focused specifically on what we can do within the context of a SharePoint page to get the best possible performance. So by focusing there, not on swamping the environment, you'll get the best results. So that's life on the farm to start. Now let's spend just a couple seconds talking about the reality of plumbing too, because plumbing is present whether we want it to be or not. And by plumbing, I'm talking, of course, about the network infrastructure that sits between your client workstations and SharePoint Online. The network infrastructure, of course, is always a factor, but when you're on your own network, when the SharePoint servers are in your environment, particularly for organizations that are not geographically distributed, the network equation is simplified tremendously. We're typically talking about Ethernet backbones that have pretty high capacity. Most people are gigabit, sometimes higher nowadays. Latencies are very low. You're generally not traversing tough to quantify pipes like the internet. You're not going through web proxies, things like that. But now that we're going to SharePoint Online, there's a lot more in play. There's Microsoft's network, there's our network, and of course there's the public internet, unless we happen to have something like ExpressRoute implemented, where we've got more of a dedicated and direct pipe between our environment and Microsoft. Most people aren't using ExpressRoute, they're traversing the internet, and so the internet comes into play whenever we're starting to talk about performance. So the network needs to be part of the discussion when we're assessing end-to-end performance. And we really need to understand that that plumbing carries everything we care about. So it's easy to abstractly refer to it as the network, but routing, traversal, redirection, all that sort of stuff comes into play. I'm not saying we need to start there from a troubleshooting perspective, but if we eventually end up in a situation where if the network, is out of whack, it can make it look like SharePoint Online is out of whack. Now, for our purposes, it's going to be easier more often than not. Most of you, I'm assuming, are developers. You're not network engineers, and you don't have end-to-end visibility on your own network. Some of you might, in which case you might want to start with the network because the network is in play in many cases. But SharePoint Online, from a developer's perspective, is going to be a little easier to wrangle with, which is why I like to start there. But when you connect to SharePoint Online, as you can see here, you're actually connecting out through the internet. You might be interacting with content. In fact, you are interacting in most cases with content delivery networks. We have internet peering and routing, so many of you probably connect to like a level 3 backbone provider or something like that to get to Microsoft's Edge nodes. Microsoft's Edge nodes are your ingress point to the Microsoft network, and once you're on the Microsoft network, you're actually in pretty good shape. Microsoft shuttles things between regions and certainly within region pretty quickly. And in many cases, when I'm trying to troubleshoot network problems, one of the things I focus on is getting people onto the Microsoft network as quickly as possible. Not going to a different geographic region and trying to get on the network, but getting onto it in their local network environment. And that can save a lot of problems. So once you're on the network environment of Microsoft, you're doing pretty well, but as you can see, there's a lot in between. So we don't have time to cover all the plumbing this time around. In case any of you are going to be at SharePoint Fest Denver at the end of May, I actually have a half-day workshop that's based around this. It's going to cover in more depth all the stuff we're talking about right now, but there's another half to it as well, and that's all the network plumbing and stuff that you have to work with and things you can do to help there. Everything from identifying if web proxies are getting in your way, if you're being routed around regions, all the way down to things like TCP window scaling and smaller things like that. So if you're going to be at SharePoint Fest Denver, I'll be there, and this will be a half-day session at the end of the week, so maybe I'll see some of you there. So in any case, if you spend a lot of time on SharePoint Online and you've kind of run out of options, you've done everything we talk about today, it's probably worth zooming out, considering the network, and getting your network folks involved to help you out. And it's worth pointing out that Microsoft has some really good tools that can be brought to bear on these sorts of problems as well. Alrighty, so let's say, all right, it really feels like there's a tangible performance problem. Users are complaining, you've seen some weird behavior, but how do you prove it objectively? Because there are so many times that performance problems, it feels like there's a performance problem, but people want data. And to troubleshoot effectively, you really need objective data. So how do we do that? Well, the good news, of course, is destruction of computer equipment is not necessary. You might feel compelled to do it, like this woman here, but I've got better options for you. So I'd like you to meet your primary diagnostic tool. In all likelihood, you already have this on your system. Some folks may be thinking, I know where you're going with this. Hello, Internet Explorer. Or really, hello, any browser, but I'm going to be using Internet Explorer. Some of you might be like, you're kidding, right? I use a browser to find problems with a site. Yeah, you do. I'm not kidding. There are plenty of built-in tools nowadays, the development tools that are part of Internet Explorer and several of the other browsers that are out there are really first class. It used to be we'd have to use something like Fiddler. I still use Fiddler for plenty of things. Fiddler, the capability set in Fiddler goes far beyond something like you get with Internet Explorer, The reason it's good to use a browser, though, instead of Fiddler is quite simply because if you want to look at traffic inside an SSL tunnel with Fiddler, there's a few things that you've got to do, extra steps that you've got to do to set Fiddler up to do that. Internet Explorer and the other browsers don't have that issue. So you won't have to worry about that at all. You just kind of fire it up. The way we get to Internet Explorer's browser tools is by hitting F12. And some of you have probably done this before. You hit F12 and you get this that pops up. Let me go ahead and go split screen here so you can see what I'm talking about. Tell you what, let me go ahead and expand this because it might be tough for you guys to see some of this. So let me, we'll zoom in here. Of course, that doesn't help for the diagnostic window. It's just the browser itself. Okay. In any case, you'll be able to download this and play this back if you want. Tom's recording this. And if not, I'm actually in the process of trying to finish up an article on how to do this. So I'll have plenty of screenshots there as well if you watch my blog. You start on the DOM Explorer tab here. And of course, I don't have Zoom It turned on. Let me go ahead and turn Zoom It on for just a second. Pardon me, I should have already had this set up, but this will give us someplace, this will give me a little bit more capability to go out and give you guys a closer look at what I'm doing. So turn on Zoom It, and now I can go in, ta-da, there we go. So we start out here on this DOM Explorer tab. The tab we're interested in, surprisingly, we're not interested in performance. We want to go over to the Network tab. And when we go to the Network tab, we end up looking at the series of interactions that takes place between the browser and the server on the other side. And in this case, we're talking to a SharePoint Online web front end. So when I go and request a page, you'll notice for every interaction that the browser has with SharePoint Online, we get another line down here in the bottom. And the reason for this, you might be wondering, my gosh, what are all these interactions? Well, of course, we're requesting a single page, but to render that page, your browser has to go and fetch all sorts of things like JavaScript, CSS, images, all sorts of other assets. And so every time it's got to request one of those things, it's going out to SharePoint Online and requesting that asset. So if we look over here on the right, on the left-hand side, if I can do this without, there we go. So you'll notice a number of JavaScripts, init.js, init strings, core v15 CSS. This is Microsoft's out-of-the-box CSS baseline style sheet. We've got everything from standard GET requests, XML HTTP requests. This is an out-of-band AJAX request. The page request, though, the one that we're most interested in here is home. And when we start doing baseline analysis, my default page, this is the Pate group intranet. Our default page is home.aspx. For many of you, it's going to be default.aspx, but you're looking for, if you want to identify the page in your environment, it's going to be text/HTML, and it's going to have a type of document. Everything else will be, scripts and links and you name it, images. We have all sorts of things down here. I'll show you some of the other ones that you might see. If I can do this without. There we go. I keep clicking off screen, and of course it keeps nope. Try it again. One more time, and then I'm going to call it. There we go. So ICGen, GIF, SP init.js. These are various scripts that are needed to power some of the capability under the hood. Here's our Pate group logo. Image, scripts. It's pretty easy to read this. Of course, you also get various codes. This is a good place to identify some maybe broken links and things like that. And we can do that by taking a look at the result description here. A 200 in HTTP parlance, that's an OK. That's a successful request. Once we get into caching and talking about caching, anytime a request is made for an asset that you happen to have cached in your local system, in the browser cache, if it hasn't changed since the last time it was fetched from SharePoint Online and brought to your browser, you'll get a 304, which means not modified, and it's safe for the browser to use the copy it has locally. Now, if the asset has changed, what it'll do is refetch it, store it in the cache again, and you'll have it available to you for next time. So this is why sometimes, the browser cache will see variable numbers of requests to SharePoint Online, because if something's cached with a public cacheability header, that is, there's a max age assigned and it's available to the browser to cache it, the browser will actually store it for your entire session, and then oftentimes beyond that, and it won't even call back to the server to get it. This creates a number of interesting problems for different people. If you look on my blog, I have a number of different articles I've written about SharePoint's blob cache, and when people monkey with the max age too much and sometimes get into these situations where they can't change the image for people who are visiting the site, sometimes it's due to interactions with the blob cache and these assets which are being pulled down and stored in your browser. But the 304 here just means, hey, I've got it locally, it hasn't changed from the server, so I'm not going to refetch it, I'm just going to use the local copy I've got. So, we could spend an entire session, and I'll spend more time in Denver going over all this stuff. But what we care about here, like I said, is the home.aspx page. So let me go ahead and find that. I did the refresh. There we go. Home.aspx. I got a 200 and OK. Text.html. I pulled down 58.21 kilobytes. Took 627 milliseconds to send that request out and basically get the data back, which really, that's not too bad. That's a little over half a second. Going from your browser to SharePoint Online in half a second, hey, that's pretty good. That number is where a lot of people stop. They'll say it took 627 milliseconds. I guess that's okay. That gives us a certain amount of information, but that number by itself is not particularly useful. Where things start to get really interesting is when we start looking at headers. So for those of you who aren't familiar, or at least aren't familiar enough with the way that your browser interacts with a web server, your browser, anytime it makes a request of SharePoint Online, there's metadata about that request that your browser will pass, and that goes in the form of request headers. Request headers can be anything from the type of language that your browser accepts, cookies, including authentication cookies, all of these request headers, including the agent. You've probably heard about the user agent before. This is where the browser identifies itself to the web server in case the web server does things differently for different browsers. All of that ends up as a series of request headers. By extension, the server can supply our browser with metadata and additional information with response headers. And there are a few interesting response headers for us from a page that gets served up from SharePoint Online. 3 in particular are worth looking at, and I spend my time looking at them. So let's see here. Let's start with the one that I've got highlighted here, SPIIS latency. SPIIS latency is a measure of the amount of time that goes between the web server or SharePoint receiving our request and then taking action on it. So in essence, this is the amount of time that the request spends queued on the server before the server starts processing it. 0 here is very good. That's 0 milliseconds. It means that SharePoint started acting on the request as soon as it came in. Now, if there's a large volume of traffic, a large number of requests being issued against the web servers, this may start to creep up a bit. It's usually only a handful of milliseconds because, again, remember, SharePoint Online is doing its best to keep the web front ends from being overloaded. So ideally, we should not be spending a lot of time waiting on the request to be processed. So that's one measure we care about. The next one is SP request duration. Now in this case, SP request duration is 425. This means that the SharePoint server spent 425 milliseconds processing my request. So from the time it got it, it started acting on it, and then started sending data back to me, it spent 425 milliseconds processing, which isn't bad. That's not a heavy page load. That's pretty good, in my opinion. So this obviously is in milliseconds. It can go lower than this. It can go quite a bit higher than this. Once you start to get into thousands of milliseconds, this is oftentimes when users start yelling. You know, if you start to see 5,000 milliseconds, 10,000, 20,000, you know, 1,000 milliseconds is 1 second. If you're looking at 15,000 milliseconds, that's a 15-second processing time on the page. There's something wrong there. And that's ideally what we want to figure out what's going on. Now the final number I want to show you, and this is one that many of the folks who have admin chops will recognize. SharePoint has had this for a while, the X SharePoint Health Score. This is a number between 0 and 10, and it is a relative rating of how busy SharePoint on that web front end is at the time of processing. 0 means that SharePoint's processing everything without issues. 10 means the server's probably ready to fall over because there's so much activity. Now, SharePoint Health Scores and SharePoint Online almost always are very low, maybe 1, 0. I've never seen anything particularly high. That's not to say it doesn't happen. But again, that automatic provisioning process to bring additional power in to serve up pages and keep CPU utilization around 40% helps keep this low. Now what happens as this number goes up is SharePoint starts to selectively suspend certain processes within the farm until activity dies down. So if you happen to have timer jobs, for instance, that have a low priority rating, those may be temporarily suspended until SharePoint clears off everything that's going on. Additionally, if you have things like search queries, for those of you who've played with the content search web part, you may have seen that you can set the priority at low, medium, and high for that content search web part. That ties directly into this health score system too, because if you set a low priority for your search request, then, or your search content search web part, then the X SharePoint Health Score might only get to 3 or 4, and your content search web part will be selectively suspended in what it does. Now, if you set a high priority for your search query, then the SharePoint Health Score might have to go much higher, maybe up to like 8 or 9, before SharePoint starts to suspend it, because you've told SharePoint, hey, the results of this search query are very important. Don't suspend them for any reason, even if you're unhealthy. So the X SharePoint Health Score, ideally for our purposes in troubleshooting, needs to be low and should always be low. And I say always with a, an asterisk next to it. I hate to make absolutes. So those are 3 headers we care about. And when we look at our SharePoint page, if we get the numbers associated with those, this is where I'm going to go back to my, my presentation. If we start to take those numbers and mess around with them, there are a handful of things we can do. So the ones that, again, that I want you to watch are the SPIS latency, the SP request duration, and then the X SharePoint Health Score. If we take those numbers and we take also the amount of time that the browser has identified it's taken for a request to be processed, we can start to do some interesting math. If we take the overall time, so in this case, the overall time, I'm talking about, whoops, I didn't need to do that. There we go. If we talk about overall time, so this is the, in this case, 2.01 seconds, okay? The browser says it's going to take 2.01 seconds for everything to come back. If we subtract from that the sum of the IIS latency, which is the amount of time we spend waiting, and the request duration itself, this is the amount of time either waiting or processing at the server. This is the overall amount of time as observed from our browser. If we subtract this from this, we can infer that this is time lost elsewhere. More often than not, traversing the network, dealing with network appliances, or other hiccups that are network related. So anytime you have a time that, and you subtract the latency and duration, and you have hundreds or thousands of milliseconds, that's almost always a sign that there's a problem with routing along the way. And I'm using routing in a generic sense here, not specifically network routing, but it hops along the way. This can be due to delays that are being added by web proxies, sometimes by firewalls. If you're working for an organization that's geographically distributed and requests are being routed, let's say transatlantically and then into a SharePoint environment and then coming back, that can add a lot of latency. You may also suffer bandwidth constraints, so it's taking longer for data to traverse back. But there are plenty of possibilities here. So high SP request durations are usually indicative of lots of activity and it's taking a lot of effort to render your page. Time lost, large numbers here when we do this equation indicate a network. So we can usually infer where the problem sits. It's not a guarantee, but if you're going to wet your finger and put it into the wind, it'll give you a direction which way things are blowing. So that's the magical equation. That's the 5-minute, and I'm writing an article, like I said, 5-minute troubleshooting guide. It'll be out relatively soon. But that's more or less what I emphasize here, because within 5 minutes, you can get a rough idea if the problem's with your page, with the SharePoint environment, with the network, or a combination of the three. So let's say you've concluded that your pages are slow, and you have the data to prove it. That SPIS latency is low, the SharePoint health score is low, but your request duration is crazy high, like 9,000 milliseconds. That means it's taken the server 9 seconds to process your page. That's not good. So repeat after me. The problem probably isn't SharePoint Online, it's my site. Now, I can't hear you guys, but I'm willing to bet that you're not sitting in there in the room repeating after me. This is the one point I want to drive home, because everybody wants to start by pointing the finger at SharePoint Online. In my experience, I have yet to run into a situation where the underlying problem is SharePoint Online. Even in part, it's almost always customizations and things that have been done. So who's to blame for this? Well, you know where I'm going with this. In all likelihood, it's the lousy devs. You know, those devs, they get in there, they mess everything up. Again, I'm a dev. And when I talk about lousy devs, let's qualify that asterisk there. Not all devs are lousy devs, just the ones who create performance problems and knee-jerk into blaming Microsoft and SharePoint Online. There are lots of reasons this happens, but I found when I'm doing development, humility goes a long way. I always assume I've done something to screw it up. And anytime you talk with Mark Rackley, he usually takes the same perspective too. It's kind of like, okay, what did I break? That's usually a healthy point to start. And when you're performance troubleshooting, it's a reasonable one too. So in the majority of poor performance scenarios, Microsoft, you know, they identify it's a combination of UI, UX, client-side code additions, sometimes questionable customizations and deployment mechanisms. And Microsoft has actually found that the slowest 1% of the pages they have in SharePoint Online take more than 5 seconds to load. And again, this is usually due to customizations. Anytime Microsoft gets engaged to help troubleshoot these problems, they're able to catalog things that are happening in common conditions and common sets of scenarios. Some of that information I'll be sharing with you today, but a lot of it you can find online as well. Now, if you don't believe me on this, let's say that you found that you've got high numbers, you honestly don't believe that it has to do with your code. You think it's the SharePoint environment. Guess what? There's an acid test for this too. What you can do is validate that in fact it is your page, or actually if it is the environment, you can quantify that too. Profile your OneDrive for Business page. For those of you who aren't really familiar with OneDrive for Business and how to implement it in Office 365, OneDrive for Business backing storage is actually a user's SharePoint My Site, and it resides within the same stamp that your intranet and any other site collections that you build reside. Now, the OneDrive for Business page, if you go online, you open up the waffle and you go to OneDrive for Business, you end up seeing a page like the one that I've got here. This is my Bitstream Foundry OneDrive for Business page. What you can do is take a look at that page. That page is not customized. There's light customization. There's very little modification to this page, and this page is optimized to perform. So what you can do is, okay, you've got a page that you suspect might have a problem, but you want to rule out that it's the environment. The page has a very high SP request duration. You go into your OneDrive for Business page in the same environment and profile that OneDrive for Business page. If your SP request duration is high for your page, but low for the OneDrive for Business page, guess what? It's your page. Now, if the OneDrive for Business page is performing very poorly as well, now you've actually got data that you can go to Microsoft with and say, hey, I suspected it was my page, I profiled it, I also profiled the OneDrive for Business page. I'm seeing SP request durations, in the thousands of milliseconds for OneDrive for Business. It might be an anomaly. You might have a farm that's overloaded and maybe, elastically it's expanding for additional capacity. You'll probably want to get several data points for that environment. But if they stay consistently high, you can go to Microsoft with that data, and I guarantee you that the support engineers are going to thank you for having done some homework before you just complain and yell that it's SharePoint Online. So keep that in mind. The OneDrive for Business page is your point of comparison for anything that you happen to see with your pages. So usually at this point it's like, okay, yeah, my OneDrive for Business page is really fast. My SharePoint pages are choking. Obviously this doesn't look good for me. What can I do? And of course, that's what we're here to spend the rest of this time talking about. What can you do? And the good news is, the path to performance, there are a lot of things we can do. Some of them are easy, and we're going to start with the easy ones. As we progress to the right, we're going to start to get slightly more dev-centric, perhaps a little more esoteric. By the time you get to the far right, usually if you're in that sort of situation, you may have not taken advantage of some of the earlier steps I'm talking about. So we'll start simple, and we'll get a little more complex, but the very first thing we need to do along this path is start with a very important acknowledgement. And this is pretty common. This realization is one of those things that, particularly for old guard SharePoint developers, it needs to be made and it needs to be clarified, because they start with a certain mindset towards customizing, and they forget about something very important. They're now in the cloud, because most developers really don't think about how the cloud and developing for the cloud differs from how you would develop for an on-premises environment. And this isn't a conversation about full trust solutions and server-side code. This is a conversation about understanding your environment and how you, in your own environment, have typically high bandwidth and low latency. High bandwidth and low latency will hide a number of bad development patterns. You can get away with a lot and sneak by with a lot by having a really good network. Once you go to SharePoint Online, anything that you do that hurts from a bandwidth perspective, you're pulling down very large assets, or you're making a large number of requests, you start to pay the cost for network latency over and over again. This is where we really start to see some slowdown, and that situation of being out in the cloud exacerbates conditions, and we sometimes lose sight of that. So you need to acknowledge that you're in the cloud. So anything you're doing that relies on heavy bandwidth and low latency, you might need to make some changes in how you do things. Because this is what I typically call, we're in the cloud now, it leads to a problem I simply call too many, too big. And I've already kind of talked about this already, but too many calls are made to the server, too many files are referenced on pages, and the files that are in use are too large. And many of these techniques, I'm about to share with you are things that you've probably already heard about. There might be a new technique or two, but let's go ahead and throw them up there and talk about them for just a second. Minifying files, especially things like JavaScript and CSS. For those of you who aren't familiar with the process of minification, this is where we run our scripts and files through a tool that can strip out white space, extra carriage returns. For JavaScript, it can rename variables, strip out comments, and then generally take our larger files and make them smaller. The smaller the file is, the faster it tends to come across the wire. We're taking fewer bytes across the wire, so time between time to first byte and time to last byte is reduced. And anytime we reduce times, we run a good chance of improving performance. Resizing images to usage sizes. This is that age-old problem for those of you who have maybe parents or grandparents who like to send the raw image files from their cameras across email. They send that 10 megabyte picture that has maybe no compression at all, is completely oversized. People do that with SharePoint too. SharePoint gives us a couple techniques to deal with that nowadays, one of which I'll address here in a second. But the best thing we can do for images is to reduce sizes, to reduce them and compress them more aggressively. Reducing images to usage sizes, this is the case where perhaps you only need a 100 by 50 pixel image to put as kind of a thumbnail of sorts on a page. And you're downloading something that might be 1024 by 768 and scaling it down. You're pulling bytes across the wire you don't need to pull. So take some time and resize those images. Do them, upload them, get your UI UX people to do this. Compressing them, JPEG format, PNG format, GIF formats, these all offer compression. They have different benefits and disadvantages. JPEG is a lossy format, but we can achieve some very high compression ratios. PNG and GIF are lossless, but the compression is going to be a bit more limited. So pick a format that makes sense. And if you need help with this, there are plenty of good articles out there, plenty of UI UX folks who have recommendations. If you're not familiar with sprite sheets, SharePoint makes extensive use of sprite sheets, and you can too. A sprite sheet is the idea of taking many different images that may exist as independent files, and instead of placing, let's say, 10 by 10, 100 files out in SharePoint, what we do is take those 100 files and we place them into a single large image. So it ends up looking like a set of stamps. These are sprite sheets. By pulling that sprite sheet down once and then using CSS techniques to basically act as viewports to different points on that sheet, what we end up doing, yes, we're still pulling down a much larger file now, but we're pulling down a single file. So the effects of latency, the amount of time we spend waiting for our request to go out and be answered, is greatly reduced. Because if it takes, let's say it takes 100 milliseconds for me to reach out to the server and get a response back. If I do that for a single sprite sheet file, I pay 100 milliseconds once. If I do that for 100 individual files, it's 100 milliseconds times 100. So yes, the sheets are larger, the payload's larger, but you greatly reduce the effect of latency on what you're trying to do. And if you're working with sprite sheets, I've got a couple links at the end. There are online tools to help you build these. And they're actually not too hard to put together. Like I said, it relies on a technique of putting everything onto a single image and then using CSS to create viewports. So you end up, your images don't, your images look as you'd expect them to on the page. It's just you're using some manipulation behind the scenes. Now, one thing I mentioned is, of course, we want to get images to the size we want to use them. If people want to work with larger images, starting with SharePoint 2013, we now have SharePoint's image rendition service. Many of you have probably seen this. Some of you may use it. In my experience, not a lot of people are familiar with it. But what the image rendition service is the ability for SharePoint. It's a service that allows you to, let's say, upload a very large, high-resolution file, and it adds image processing to SharePoint itself. So if I have a very large file that's in great detail, maybe I want to create a single thumbnail from part of that image, or I want to take a region from that image and use it somewhere, I can define those as different renditions. So my base image plus a bunch of renditions are functionally different pictures, and by telling SharePoint what I want to use, SharePoint will slice, dice, resize, do whatever it needs to, and then I can use those renditions at different points on my page. So I upload the image once, and SharePoint helps to ensure that I'm only downloading the bits I need to display the thumbnail or the section of the image. Now, the image rendition service depends on SharePoint's blob cache. This is enabled in SharePoint Online, but for those of you on premises, if you want to use the image rendition service and you don't have the blob cache enabled, for the zone of the web application you're going through, SharePoint will yell at you because it needs to store those images that it's processed to generate somewhere. It doesn't do it in memory. That wouldn't be efficient. So it ends up sticking them in the blob cache as assets that can be pulled down. Finally, something like Font Awesome. A toolkit like Font Awesome can be used in place of individual icons and associated files. So whenever you create a web page and you start typing, you put text on the page, you're encoding, you're not encoding actual images most of the time for the text that you're writing. You're just encoding, the page consists of characters that the browser then renders in the font of your choice. We can actually hijack this system a bit, and that's something that Font Awesome does. What it is a way for us to take and create a font file that instead of having letters, it has a bunch of vector images and things like maybe social media icons, happy faces, arrows, things like that. And then by scaling the font appropriately, we can actually put these images onto our pages and let the browser do all this vector computation and rendering. And we're not streaming additional bytes for an image down from online. Go out and look at Font Awesome. I've got a link at the end of this. Font Awesome 5 is being built right now. They had a successful Kickstarter a short time ago. But Font Awesome can be used to get you all kinds of image support. And the font file itself ends up getting downloaded, cached on your browser. So in many cases, you can generate all these images without ever going out to download per session each of these images that you might want to use. And so that can help improve image processing and cut down on time. So I'm going to kind of skip over this now because I know that I'm starting to, we're heading towards the 1 hour mark. I've still got a lot I want to show you guys, but go check Font Awesome. It'll show you quite clearly how it works. It's pretty cool. So that's what we can do with kind of cutting down on files, reducing sizes, and reducing the effects of latency. Now, I've talked about caching a bit, and conventional wisdom, particularly in the on-premises world, says that caching is a good thing. I myself have spent a tremendous amount of time. I give talks on caching. I've written articles. I've written tools for caching. I love caching. I think caching is a great way to accelerate performance and help alleviate bottlenecks. But the problem is when we get into the online environment, the cache ends up not being our friend. And I've got an article on my blog specifically around this about caching, You Ain't No Friend of Mine, I think it's called. But let's look at the on-premises scenario for just a second. In an on-premises scenario, let's say you've got a farm that has 2 web front ends, as I've got illustrated here. Now, if you just start that farm up, let's say the application pools just spin up, the worker processes are just starting. The first time somebody goes to request a page, they're going to hit one of those 2 web front ends. Now, SharePoint is going to have to go and render pages. It's going to have to go and pull properties, maybe run queries, things like that. And it has to basically prime the cache on the web front end to store much of this data. Once it's done that, any subsequent visitor in who hits that particular web front end will have the benefit of whoever came through, whoever came through and warmed up the system. And this is the point, many of you probably have warm-up scripts in your environment. Warm-up scripts, part of the purpose of the warm-up script is to do this for you before users ever get to the environment. Because as you probably know, a cold SharePoint environment, it can take quite a few seconds to bring a page back. And then once the environment's warmed up, it starts coming back much more quickly. The object cache in SharePoint handles a lot of the low-level, more simplistic caching for us. We can store things like site navigation in the object cache. We can store things like site properties that don't change very often, for instance, the title of a site. If you use the content query webpar to run cross-list, cross-site queries, those queries are expensive to run. They're computationally intensive. The results are cached by default in an online or in an on-premises environment for 60 seconds. And during that 60 seconds, results are reused. So the object cache does a lot for us. So the 1, 2, 3 here, of course, is by the 3rd time somebody hits our on-prem environment, scene 1, somebody goes out, hits it, nothing's primed, it's going to take a long time. Shot number 2 here, we have one web front end that's primed, one that's not. If by the 3rd time, both web front ends have been hit, we get the benefit of caching. That's, I think it's pretty straightforward. Now, in the cloud, the equation, particularly for per server memory-based caches like the object cache, the equation changes quite a bit. So in an online environment, remember, I told you that SharePoint stamp can scale up as needed. It has elastic capacity. Additional web fronts will be added. In this case, let's say you've got 50 web front ends in your stamp. Well, the first thing to note is, of course, the total number of web front ends is quite larger here. So when you make that first request to the environment, chances are you're not going to hit a server that's primed with the data that you need. So that cache isn't going to help you out much. So since there's no affinity in the online environment, the second time somebody goes in to hit that site, whether it's you, whether it's somebody else, they've got a 1 in 50 or 2% chance of hitting that server that you just hit where the cache is primed. So 2% is not a particularly good hit ratio if you're trying to get to data that's already preloaded into a cache. Now, something else we also have to contend with more in the online environment is subsequent requests. The users who are going out to hit the environment, remember, SharePoint Online is a multi-tenant environment. You are on a stamp, as are maybe hundreds of thousands of your closest friends. They have their site collections loaded. Memory pressure on the web front ends is going to be dramatically higher than in your typical web, the typical web front ends you'd have on premises. On premises, you're serving up, in all likelihood, particularly for intranet scenarios, a handful of site collections. So there's a good chance that users are going to continue to request the same sort of data. In an online environment with everybody bouncing between web front ends, once a cache gets filled, well, if something else needs to go into the cache, older data is going to get ejected. So in the case of this image, somebody goes in, you see that green box up there, maybe that's the one that has loaded data, but the red one now was data that we had loaded previously, maybe a couple visits ago, and our data has been ejected due to memory pressure. A cache ejection results in that data being thrown out because maybe 100 other requests have hit that web front end for other people's site collections. So the net effect is we can't rely on caching in the SharePoint environment. Now this impacts us primarily in two areas, and there are two significant adjustments we can make to help compensate for this. The first is navigation. Navigation in SharePoint by default is based on structural mechanisms. So every time you need to build a navigational menu, whether that's the global navigation, the quick launch navigation, SharePoint has to build a site map that links each site and subsite to one another so it knows how to present those for navigational purposes. Structural navigation in the online environment is a poor choice because in the on-prem environment, these site maps go into the object cache, so we don't have to keep rebuilding them all the time. Online, they get rebuilt fairly regularly with different users visiting. Now, building that structural navigation map, you might imagine the larger your site structure, the deeper it goes, the broader it goes, so that as total number of sites and subsites increase, it takes longer and longer to build that site map. And Microsoft has indicated, I got this out of one of the performance videos that they put together. For each navigational node in your sitemap, you're looking at roughly 8 SQL Server round trips to get the data needed to construct the sitemap. So however many nodes you have, so let's take this simple site hierarchy. You have 8 site nodes. That's 64 SQL calls. This is not a big site or site collection by any stretch of the imagination. So once you start to get out to hundreds of sites, multiple levels of hierarchy, you're generating a tremendous amount of traffic to SQL just to generate the sitemap for a single visitor. So what we want to do is actually switch over to something like managed navigation. Managed navigation, for those of you who aren't familiar with it, by turning on publishing, we're able to create a managed term set, and through managed metadata, we create a term set that represents our navigational hierarchy. We designate it as such as we're building the term set, and then we wire that term set in where our key ends up being the term itself ends up being the name for the node, and then we have a value that ends up being the link. We can wire that up, and so SharePoint loads the term set. It doesn't do this 8 round trip, or 8 SQL calls per node. It ends up loading our managed term set and all the links, and we can go ahead and use that. And that's generally a much better choice than to use structural navigation. Microsoft will tell you the very first thing they do with large sites is get you off of structural navigation. Managed navigation is usually a pretty good place for most people to land. It also has the benefit of allowing you to structure the navigation in a way that does not depend on the site hierarchy. So you can build any kind of navigational menu system you want in terms of nodes, subnodes, things like that, and it does not need to reflect your site. Oftentimes it does, but you may map people to external links or other places in your environment, other web servers, as well as SharePoint. You can do that with managed navigation. It's nice. For the ultimate performance, though, Microsoft will tell you search is a great way to go. Search for many versions now has been very highly performant. Search, going back to 2007, I remember my very first SharePoint Saturday that I spoke at was SharePoint Saturday Ozarks. This was in 2009. This was Mark Rackley's very first SharePoint Saturday. And Eric Schups was there talking about high performance techniques for SharePoint 2007. And you know what? A lot of what he talked about, I still remember to this day, he focused on search. And nowadays, search is excellent. Search is very fast in terms of pulling things back. You know, search crawls, builds an index. It's very fast to query that index. And we can actually use search with some client-side scripting to put together a highly performant navigational mechanism. Now, it's worth pointing out that, of course, I said client-side scripting. I have a link at the end of this presentation to Microsoft's additional detail on all of this, including scripting that you can implement. But you need to also be aware that that performance does come with a couple of hiccups, or at least watchouts. First, it's search. So if it hasn't been crawled, it's not going to be available in search. Second is, if you want to customize the menu structure at all, the navigational menus, you're going to have to get good with client-side scripting because you're constructing your navigational structures through JavaScript. So if you don't know JavaScript, it's going to be much harder to customize a search-driven navigational structure, in which case maybe managed navigation is the best part or the easiest way to go for you. But you do have options besides structural navigation. So, as I pointed out with navigational stuff, search can be used to boost performance significantly. How many of you, this is kind of a rhetorical question, but how many of you have users or you yourself like to use the content query web part? We've had it for a number of versions now since SharePoint 2007, and this is what users typically use to aggregate and roll up data for presentation in a single location to grab data from across a site collection. Well, in the cloud, the content query web part can cause some significant performance hits because the content query web part performs what are typically expensive cross-list and cross-site queries at runtime. We rely on the object cache in an on-premises environment to house the results of those lookups for a period of time, so we're not constantly rerunning these queries. Now again, since we can't rely on the object cache in the online scenario with SharePoint Online, we're going to be rerunning these queries more and more often, and that's going to slow down a page. So what I typically recommend, and what Microsoft recommends, is you can do just about everything with the content search web part that you can with the content query web part. And in many cases, you can do a lot more. The content search web part is phenomenal if you're trying to do roll-ups, aggregate content, and in fact present content in a way that's interactive. If you're good with JavaScript and display templates, you can present content in all sorts of ways, and it's highly performant because it uses search. The one thing the content query web part can do that the content search web part cannot, the content query web part is audience aware. So if you need to use audiences to partition what people see, then the content search web part will not natively work with audiences. Now you could probably doctor display templates to bring some audience data into it if you want to make callbacks into the environment, but that's an advanced development scenario. In many cases, people will fall back to using the content query web part, but audiences are the one determining factor for many people if they can't move away from the content query web part. So search is phenomenal. Use search every chance you can, and the content search web part is a good way to do it too. So those are a couple of things so far, and these touch on pretty easy to implement. Let's move into, we start to get into some of the plumbing, page plumbing here. So it's time for a very serious question. How many of you are web part junkies or have users who are web part junkies? A lot of people come to SharePoint, they love web parts. I can't argue with them. I mean, when SharePoint first came out, you couldn't say SharePoint without also saying web part because it was such a unique way of working with web pages at the time. Nowadays, of course, SharePoint comes with plenty of web parts. And I'm not specifically talking about app parts here, because app parts themselves, for those of you who understand the distinction, an app part is really just an iframe to content that's provided from another server. Web parts, on the other hand, oftentimes have full trust code running behind the scenes on the server, and so can generate load for the server to run. Now, if you're a web part junkie, it's probably time we talk rehab. Serious rehab. This guy needs serious rehab. There are things we can do. There are alternatives to freebasing web parts. Unfortunately, there's no single or simple answer. Generally speaking, what we talk about doing here is leveraging client-side code, JavaScript, and asynchronous techniques. And when I'm talking about web parts, I'm not talking about stuff that's based on the new SharePoint framework. The new SharePoint framework that is evolving even as we speak, that's all based on client-side technologies. That's not what I'm talking about here. I'm talking about out-of-the-box web parts that have a server-based implementation and tap into and are processed as part of the page processing pipeline by the web front ends. These are the traditional, content editor web parts that people might put out there, XML processing, anything that does work on the server. Those are the web parts I'm talking about. We want to get as much of that off of the server and somewhere else. App parts, we're talking about things that leverage the add-in model for SharePoint. That's going to be running on another application server. If we're talking about client-side web parts that might be built with the SharePoint framework or through our own JavaScripts, that's running on our browser. That's fine. That takes the load off of the server. Now, it's probably also worth pointing out at this point that make sure, we're talking about web parts. One thing you can do is make sure that people haven't gone in and placed a bunch of web parts and then closed those web parts out but never deleted them. This is just good house cleaning. And most of you are probably familiar with the contents equals one query string modification you can make to the URL. Take any page, add a question mark and contents equals one, and it puts you in this web part page maintenance mode. You can see what web parts are on the page and whether or not they're open. Now, if you see web parts listed out here that are not open, you are still paying the cost to render that web part, but nothing is showing up on the page. Those web parts should probably be deleted because chances are somebody closed it out without actually understanding that closing and deleting are two different things. But every web part that exists on the page, whether it's visible or not, contributes to the page load, and by that I mean the amount of time it takes to process the page. So delete web parts which are closed out that you aren't using, and you can do that through the web part maintenance page. So we couldn't get this far without talking about the sandbox, right? Sandbox. This is a sandbox. Many of us are familiar with sandbox. This is a sandbox solution. You've probably heard some rumbling over the last year about sandbox solutions because they've, Microsoft deprecated sandbox solutions a long time ago, but things got real when Microsoft turned off the ability for most people to upload sandbox solutions that include actual code. We're talking about sandboxes. Sandbox solutions, many of you are probably familiar with these. These were an attempt by Microsoft to restore some controls to administrators in the cases where developers who had full trust control access to an environment were doing things that would potentially jeopardize server performance. And Microsoft has more or less pushed us out of the sandbox solution business. Now, it's worth pointing out that there are really two types of sandbox solutions. One of them is okay, one of them's not. Custom code sandbox solutions, that is sandbox solutions where you're attempting to deploy a DLL with compiled code, those are no-go. Microsoft, unless you have an exception, is not even going to allow you to upload that nowadays. But sandbox solutions that contain only declarative assets like HTML, CSS, and JavaScript, that's still technically okay, and you can use those. Now that I've said that, this isn't a problem we see so much anymore, so I'm not going to spend too much time on it, but previously when they did allow custom code solutions, there were validation checks happening unbeknownst to users and to folks who were pushing these solutions out that could add seconds of page overhead. But like I said, since August of 2016, Microsoft has pulled the plug on managed code sandbox solutions. If you happen to have an exception granted and you're seeing performance problems they might be tied to these sandbox solutions, be aware that certain certificate validation checks that Microsoft or SharePoint Online is trying to do could cause problems for you. It's more of an edge case. I want to call it an edge case, but I've seen it in 2 different instances now, so it's not as much of an edge case as I would have maybe liked it to be. So let's go ahead and skip over that to something that's probably going to be a little more important. Sometimes perception is everything, right? And when we're talking about performance, sometimes a page may actually load quickly, but it feels slow to users. And to them, if it feels slow, regardless of whether it being fast, it's the same as being slow. What do I mean by this? Well, oftentimes we do things that block rendering in pages, and what we need to do is develop our asynchronous programming techniques. Now, by default, JavaScript is not going to let us. JavaScript helps us along here, and jQuery helps us along here. We're not allowed as developers, client-side developers, to block the main thread of execution in a browser. So everything we do is asynchronous already, but there are different ways to handle asynchronous programming. Some are good, some are not so good. Any of you who are familiar with jQuery have probably used or at least heard about promises. If you're like me, I come from a classical, I used to be the guy who wrote middleware services, excuse me, multi-threaded code. I'd build APIs for other developers to use. I got real good with compiled code, and so I approached things from a compiled code perspective, which is oftentimes synchronous execution. If I was doing things asynchronously, I was specifically doing multi-threaded execution, and I had, of course, my wait handles and mutexes and semaphores and all that sort of stuff. Well, in jQuery, we are inherently asynchronous, and for a developer like me to come into the realm of JavaScript and try and build solutions that use JavaScript, I sometimes get thrown off by this notion that the code's just going to keep on running, and if I'm making web service calls, REST-based calls, CSOM calls, JSON calls out to SharePoint Online, code execution is not going to pause for those calls. I can do certain things to block, and I can do certain things to approximate a synchronous programming pattern, things like using promises. These are techniques that you as a developer will want to get good with, because ideally what you want to do is make the asynchronous nature of the browser work for you. Don't generate calls and block rendering in a way that's going to leave a user, for instance, with a blank screen. Instead, if you have data put in a container, make sure the container shows up, make sure the container draws. And if it takes some time to get the data from a REST-based service, fill that in later, but make sure the user sees the container. This can help remove problems, or at least prevent users from coming to you saying, hey, the page isn't loading. Because I've been in more than one scenario where somebody has said the page isn't loading. I go and I observe for myself what's happening. I immediately see the sweet links bar come in, so I know the page is loading, but the way that they've structured their JavaScript, the page stays white until a whole bunch of web service calls come back. You don't want to do that. You want to make it look like your page is actually loading. So to the extent that you can put things on the page, even as other calls take longer to come back, you're going to make things easier for yourself, because your users will at least see something happening. And again, if they see something happening, even if it's not the data they need back yet, they see something's happening, they know the page isn't stuck, or they don't think it's hung. I hope that makes sense. So speaking of asynchronous techniques, there's a bunch of different things we can do. And there are libraries to help with a lot of this stuff. So what I'm doing here, you can see Facebook and LinkedIn are perfect examples of this notion of only loading what you need. When you bring up Facebook, when you bring up LinkedIn, everything that appears above the fold, that is what is shown on your screen, that's what gets rendered. Anything below the fold, that is stuff that's off screen at the time, which is grayed out here in this page on the right, that doesn't get loaded until a user scrolls down. And when a user scrolls down, that stuff can be brought into view. So there are libraries to help you do this with SharePoint and other web pages as well. Lazy load images and things like that. Don't load things until you need them. That way you minimize the amount of time you're spending pulling items across the network, and you're also making the page from a user's perspective more responsive. All right, so finally, Ask yourself this question, for all you developers out there: how well do you know the code and libraries you're using? There's a very specific direction I'm going with this, because when I'm troubleshooting performance issues, I commonly encounter a pattern that can be illustrated with the following diagram of stages. Now, as we're learning new domains, this is typically at a macro scale what's happening. We're looking to increase our knowledge, and the more time we spend doing something, our knowledge increases, right? For those of us without a flat learning curve, some people, they can spend as much time as they want. They never actually progress, but ideally we all follow this kind of curve here. So stage one, if I'm a developer, if I have a problem, in stage one, I acknowledge I have a problem to solve, and a good developer will oftentimes say, hey, has anyone written this code before? I don't need to reinvent the wheel. I would just like to get a solution that works for my problem. So for a JavaScript developer, the very next step tends to be, hey, there's probably a library for this, or maybe somebody wrote one. Let me see if it'll work. I found something. Let me see if it'll work in my project. Now, stage three is, hey, I've wired it up. I've got the library. I'm passing parameters properly, handling it. It looks like it works within my project scaffolding. Now, when we get to stage four is you understand the library internals at least well enough to know that it won't cause any problems with SharePoint Online. Ideally, you understand anything it's doing under the hood better, but you at least want to know that it's not causing problems. Now, it probably doesn't surprise you to hear me say that most developers don't get to stage four. Most developers on this curve usually bomb out somewhere around stage 3.2-ish. The demo code worked. I tweaked it. It's doing what I need. I don't know what it's doing under the hood, but hey, I need to move on to something else. I've got a deadline to hit. I've got a project to deliver. It works. I'm not going to worry about it. So at that point, they basically do a hard stop, right? How many of you are like this? I've done the same thing myself. You do that hard stop. The problem is when you do that hard stop, you're more or less looking at a powder keg that could go off, because if you don't understand the libraries you're implementing, you don't know from a performance perspective what that means. So I'm going to give you an example here. And this is an example that I sought this man's approval before I did this. Many of you probably know this guy. You've seen him around. He does a lot of really awesome stuff in SharePoint, and he has done a world of good to help the SharePoint community, particularly the client-side development community. This man is, of course, Mark Anderson. Mark Anderson's based up in Boston. He's a creator of SP Services, and this guy is he's certainly one of my go-to people for client-side development and those sorts of techniques. Now, before we had all the cool REST APIs and CSOM JSON, before we had SharePoint 2010 and some WCF endpoints, the only way we had to work with SharePoint in a web services capacity was through the old ASP.NET 1.0 ASMX endpoints. This is the stuff that relied on SOAP, CAML, all that sort of stuff. Mark wrote a library called SP Services that simplifies working with those endpoints. And it's still heavily used today because it works for pretty much every version of SharePoint since 2007. And it works with SharePoint Online. You can use it everywhere. Now, the last check, this is still very popular. SP Services, I went out today, I checked, greater than 46,000 downloads for the current version. Tons of people use this. It's a very popular library, and some of you probably used it too. So getting back to the whole know your code libraries and how they work, as Mark will tell you, SP Services works just fine with SharePoint Online. But even Mark will tell you there are probably some things you shouldn't be using SP Services for when it comes to SharePoint Online. And I still recall a couple years back, SP TechCon had a developer-focused conference out in San Francisco, and this is back when Mark broke his leg. He and I were sitting on a bench eating ice cream, and I said, hey Mark, I want to talk to you about SP Services, and I want to talk to you about SharePoint Online and some performance problems I'm seeing. And he kind of smiled. He's like, I think I know where you're going with this. And so we talked about this particular method. So SP get current user. This is some JavaScript code that I had pulled out of a project that somebody I knew had written. and they were running into some problems. And they were making this SP services call to SP get current user. SP get current user provides information about the current user who's interacting with the page. So it's a way to provide what you might consider user profile information. Okay, it works just fine with SharePoint Online, but there's a big problem here in terms of performance. If you've not used the SP get current user method, you might not know what's going on. If you have used it, you also might not know what's going on. Behind the scenes, SP get current user, back in the 2007 days, there wasn't a user profile service endpoint that we could get to actually pull data about the current user. So what Mark did with SP services was he actually issued a call to the user's profile page in the layouts area, and he scraped the profile information that came back on that page. So I had a developer who was innocently using this SP get current user in a JavaScript that they had written, and they were calling it multiple times and not necessarily they weren't caching the results. So every single time this method was called, it generated another page request to SharePoint, which of course engaged the whole user profile engine to dump all this stuff into HTML, and then SP services had to scrape it. So as you might imagine, removing that call, or at least limiting its use, we drove a very horribly performing page down into something much more reasonable. And as you can see here, just by switching over to a REST-based call against current endpoints and dropping that SP services call, we saved a dramatic amount of time. It's not even close. We went from almost 15 seconds to under 6 seconds. So this is just an example of, if you don't understand the scripts that you're using and you're suffering performance problems, it might be a good idea to actually go and profile what some of those scripts are doing, because you might unknowingly be doing something under the hood. So the quick summary here: don't treat SharePoint Online like your own on-premises SharePoint farm. The two operate very differently. Server-based caching, of course, isn't your friend in SharePoint Online. Your browser can be your best friend when troubleshooting, and know the code you implement, or at least profile it before you release it. So I hope you found some of these techniques to be of use in some of the discussion. Maybe gives you some ideas for excuse me, what you can do in your environment to help troubleshoot. Like I said, these references, download the PDF. I'm going to scroll through all these. I'm going to get to my, of course, thank you. And here's where I'll leave things for now. And like I said, this PDF is already out on my site, on my blog. So if you go to SharePoint Interface and you go to resources, you'll find this sitting right at the top, and you can download it. Feel free to ping me if you've got questions. And I know we've got more questions. So, Tom, what you got for me?
All right. So we are at the time limit, so I'm going to let the people that want to go home and drop off.
Thanks for coming, folks.
Yeah, we really appreciate you taking the time to talk to us, and that is a lot of information, and I hope a lot of you go back and rewatch this video, which will be posted online. We're going to stay online for those that want to stay. If you want to drop off, that's fine. We're going to answer the rest of the questions that are in the queue, and we have a couple questions here as well. So that's it. We want to thank everybody for joining, and we're going to cut to the questions now.
Excellent.
We have a couple of, there's some live people.
Thanks, guys.